All right, so picking up from where we left off, we have a complex number here, 4 minus 3i, and we're going to take the absolute value of that number. So what we're looking at here is we have two different types of numbers. We have one number is the normal number, our regular old integer, okay? So this is a regular number or a normal number. And we've also got this negative 3i, which is an imaginary number or a non-real number. I'm going to put this here. So non-real number. Cool? So we have these two different axes that are kind of playing off of each other, and we're actually going to use this to find the absolute value. What I want you to remember is the absolute value means we're finding the distance to 0. Okay? At this point, right here, both the real number and the non-real number are 0. Looking at these, however, obviously our numbers aren't 0. They actually have some distance to them. So this one is a positive 4, so this one's going to be somewhere over here. We'll say like right here, 4. And then our imaginary number is negative 3, so it's probably right about here-ish, negative 3. And where these two lines meet, right about here-ish, that is this point. That's kind of what we're looking at there. Okay, so what we're trying to find is from this point back to 0, the absolute value, we're finding the distance from this point back to 0. This is our 4 minus 3i. Cool? We have our 4, we have our minus 3, and here we have our 4 minus 3i together. Our distance from here to 0. Now, the important thing about this is that this actually does make a right triangle for us. Ta-da! And that right triangle means that we can actually use the Pythagorean theorem to figure this out, which is really, really helpful for us. So 4 is going to be one leg of the triangle, negative 3 is going to be this other leg of the triangle, and our hypotenuse is going to be this 4 minus 3i. And when we solve that, we are going to find what the absolute value, the distance to 0, this complex number is, okay? So I'm going to erase this. This, again, this picture is just, whoa. This picture is just trying to help you understand, what this actually means. So I'm going to get rid of all this. I'm going to start from scratch. So we have our A. This is our B value. And then our missing value here is actually the C. So we're going to do the Pythagorean theorem of a squared plus b squared is equal to c squared. Cool? So it's kind of funny because this is a complex number, but the I actually doesn't matter for us at all. We're just kind of plucking these numbers out. So my a squared is going to be 4. It's 4 squared. My b value is going to be negative 3. So I have negative 3 squared. I'm going to throw that negative into a parenthesis. And then we don't know what c is yet. Cool? And this works exactly like the Pythagorean theorem. There's really no difference to it. 4 times 4 is 16. Negative 3 times negative 3 is going to give me positive 9. Is equal to c squared. 16 plus 9 is going to give me 25. Is equal to c squared. And my last step here is to simply take the square root of both sides. Because I want to get c, not c squared. So I'm looking for c. So I'm taking the square root. That'll give me regular c is equal to the square root of 25. Which is, simplified, the square root of 25 is just 5. So the answer, what is the absolute value of 4 minus 3i? It's simply 5, which seems almost like an absurdly simple answer, but this is actually just an absurdly simple problem. So the answer for something like this would simply be the number 5. All right, so I'm going to erase this. We're going to take a look at the next problem. This one on your sheet, on your worksheet there, was number 16? 16, number 16. So number 16, once again, we are doing the same thing. A squared, b squared, this is my a squared here, negative 9, My b squared is negative I. Again, we got to remember it's invisible, but there is a negative 1 here. And this is going to be equal to my mysterious c squared. That's what we're looking for. Okay? Once again, plug these guys in. Negative 9 squared. We have plus, my b value is going to be negative 1 squared. And is equal to c squared. And again, we're looking to find c, just like any other Pythagorean theorem problem. 9 times 9 is going to give me, 9 times 9 is going to give me 81. Or negative 9 times negative 9, it gives me positive 81. Negative 1 times negative 1 gives me positive 1 is equal to c squared. 81 plus 1 gives me 82 is equal to c squared. But I'm not done yet because I'm not looking for c squared. I'm looking for c. So I need to take the square root of this side and the square root of this side. So my final answer, c is equal to the square root of 82. So the answer for this one is the square root of 82. That is the absolute value of negative 9 minus I. And that's it. Again, remember, we're just finding the distance to 0, and we're using the Pythagorean theorem to find that distance. The next one that you have is a little bit different. We have a fraction where we have the imaginary number, the I, in the denominator. And for most mathematicians, that's illegal. You cannot do that. We got to get rid of this I. So our objective here is to eliminate the I from the denominator. Our first thing that I want to focus on is that tool we were talking about earlier. I is equal to the square root of negative 1. You know, it's a number that doesn't exist. Hold on 1 second. I'm afraid that I messed the zoom on this up on this. I hope that I didn't. This might actually mess it up a little bit more. We're going to see if I can fix this real quick. Okay, I hope that fixed it. Let's see. Is equal to the square root of negative 1. And we know that I squared, if we were to square this value, it's just going to be negative 1. It eliminates the square root. So as soon as you square an imaginary number, it becomes a very real number again, negative 1. All right, so when we're looking at this, we have negative 6 over negative 6i. We need to get rid of this I. To do that, we are going to actually multiply it by another I to make it I squared. So I need to multiply this by I to get I squared. So it cancels out the imagination, or the imaginary part. However, I can't just do this to the denominator. I have to do it to the numerator as well. So I'm going to multiply the numerator and the denominator by I. So this is going to come out to, my top is going to be negative 6 multiplied by I. And my denominator is still going to be negative 6i, but now it's going to be I squared. Now we can actually use this rule here to help us out. The top is still going to be negative 6i. However, the denominator is now going to be negative 6 multiplied by, and we can sub this out for negative 1. Once again, this is going to be negative 6i. The numerator does not change. And on the bottom, we're going to have negative 6 times a negative 1, which actually gives me positive 6. So we have negative 6 times I over positive 6. And now we do not have an I in the denominator anymore, which is great. That's what we want. And now we can actually simplify this. Negative 6 divided by a positive 6 is going to come out to be, negative 6 divided by a positive 6 comes out to be negative 1i. And that is my final answer, negative 1i. Let's take a look at one more example that's a little bit more complex, but not too bad. We have this one where we have an expression on the top and an expression on the bottom. And again, we are going off of this very crucial rule that says I is equal to the square root of -1, and I squared is equal to -1. And again, this is great because it cancels out I. It gets rid of it. Now, if I was to do the same thing I did last time, multiply the numerator and the denominator by I am going to run into a problem. Here's why. If I start this off, I'm going to have -4. This I needs to multiply by both this number and this number. So I would have -4. In other words, when I'd get to the next step, I'd have -4 times I is -4i. And then I would have 10i multiplied by I, which is going to give me 10i squared. And that I squared is great because we know this will eventually cancel out to be -1. However, we still have an I here. And that's where we're going to run into a problem. There's no way I can just multiply by I alone and cancel it out. It's always going to exist in some way, shape, or form. So instead of multiplying just by I, we have to multiply by what is called the denominator's conjugate. And a conjugate is not something that's difficult. The conjugate only means you're going to write the exact same thing that's down here, -4 plus 10i. And to make it the conjugate, you're just going to take the imaginary number and you're going to flip the sign. So for this one, instead of a +10, it's now a -10. So that's all you have to do. So now you're multiplying the denominator by its conjugate. Again, the only difference is the imaginary number has an opposite sign. And if I'm doing that to the bottom, it's only fair that I multiply it by the top as well. Same thing, okay? -4 minus 10i, -4 minus 10i. So now it starts to solve exactly like the previous one did. I have to go through and do my distributive property here a little bit. So I have 1 times these two values. So 1 times -4 is going to be -4 minus 10i. That's 1 times -4, 1 times -10. And then for my 10, I'm going to have 10i multiplied by -4, -40i. And then 10 multiplied by -10i, which is going to be -100i squared. Now on the bottom, I have -4 times -4, which is going to be +16. -4 multiplied by -10i is going to give me -40i. I'm sorry, that's +40i because they're both negative. So -4 times -10i is going to be +40i. And then my 10i, I've got 10i times this, -40i. And 10i multiplied by this is going to be -100i squared. Okay? So, and yep, that's cool. So now we have this number here. It looks big, it looks complicated, but there's actually a lot of shortcuts that are going to help us out here, and that's great. A lot of this is going to start canceling itself out, okay? So first of all, when we're looking at this expression, let's see. First of all, we want to look for our I squares. Again, our I squared is going to be what cancels things out for us, which is really good. So right off the bat, actually, hold on. Yeah, right off the bat, all of my I squareds are going to turn into -1s. So this is going to be -1. This is going to be -1. And there's no other ones there. Now, something else I want to take a look at. This is what the conjugate did for us. We have +40i and -40i. So these two are actually going to cancel out. We have +40i and -40i. Those two cancel out. So that's already kind of making my job easier there. On the top side, we don't really have anything that can cancel out yet, okay? I'm going to take one step backwards. I'm going to actually kind of move this backwards so I have a little bit more room here. Erase this and doot. I'm going to bring this backwards so I can continue working on it. So my next step is I'm basically just simplifying this stuff out. So I'm looking at the top. I have -4 and the 100 being multiplied by -1. This is just going to cause the sign of the -100 to flip, so now it's a +100. Same thing down here. This is now going to be a +100. I have -4 plus 100. That's going to give me a +96. So this one is out, and this one's out. Then I have -10i and -40i, which is going to give me a -50i. Yes, and now these two are out. So all I'm really doing is kind of scratching these numbers off as I'm combining them or canceling them. So the top is all good. There's my numerator. Looking good so far. These two canceled out, so I'm left with +16 and +100. So that's going to be 116. So 16 plus 100 gives me 116. Now it's starting to look a lot cleaner, which is really nice. And actually, at this point, we're basically done. The only other thing I would do here is I would actually flip-flop these two. So instead of the 96 being on the right-hand side, this is just kind of proper nomenclature. I'm going to scooch the imaginary number back here and put the positive number up front. And now we have a finished product. So all I did was went through, I multiplied by the conjugate, I went back through and kind of distributed everything out. I simplified and canceled out what I could, and now here I have this. I have on the top a complex number minus imaginary, and there is no imaginary numbers on the bottom. So this would be my final answer. Cool. I hope this helped for you. At the very least, you can always rewind and go back and rewatch parts again if you need to. And yeah, good luck on your quiz. Bye.